Now that you've done the lab, you should know the difference in how land and water heat. So let's go ahead and do a little bit of lab debrief. So starting out, what was the difference in how land and water heated? Well, hopefully you saw that land heated much faster than water, and land also cooled much faster than water. So there is a very big difference. Your bucket of dirt should have gotten warmer very quickly, and the bucket of water should have taken a much longer time. Once you turn the lamp off, the bucket of dirt should have cooled off much more quickly, while the bucket of water cooled off much more slowly. So based on this lab, based on those results, what would be the difference in how land versus oceans are heated by the sun's radiation? I'll go ahead and let y'all pause this video and just give you a quick second to discuss that. Okay, so just as the question before it was asking, and just as I've already told you, the beach in this picture, this would be much warmer during the daytime than the ocean would. So if you were going to go stand on the beach, and some of you may have noticed this before in the past, but if you're standing on the beach and it's really sunny out, then the sand might be really hot and burn your feet. Well, why is that? That is because the sun is heating up the land very quickly, so very fast, so it gets hot very fast. And this water, if you finally went to jump in to cool off, it would still be very cold because it's going to heat much more slowly. So the sun's radiation, especially in an image like this, you're going to have an extreme temperature difference. You're going to have the really hot water, or the really hot land, and then you're going to have the very cold water. So that's going to be a big difference. Now, the next question I want you to kind of imagine, or it may not be the next one, but one of these questions, I want you to imagine a scene like this when we talk about wind. So let's see what our next question was. Okay, so how does this help you explain, this isn't the beach picture, but how does knowing that the land heats faster than the water help you explain why it's often milder? Milder simply meaning less dramatic temperature differences in coastal areas, while inland places have more extreme differences in temperature, so very big highs and lows. So the places that we're looking at are San Francisco, California, over here, and then Wichita, Kansas, which is going to be in the middle. So looking at this picture, I'm going to let y'all pause the video and to discuss why is San Francisco going to have mild temperatures while Wichita, Kansas has very extreme temperatures. Okay, so over here, San Francisco, because they are right by the water, and that's water in case you're wondering, so because they're right by the water, this water is going to heat up slowly and cool down slowly. So if you were to graph it, it would go warm and then it would cool off. The graph would look more like that. Kansas has no water next to it at all, so there's nothing to help regulate its temperatures. So if you graphed its temperatures, it would shoot up and then it would shoot right back down. Notice their high temperatures in July are in the 90s and their January low averages are in the 20s. Versus here you have 70s to almost 50. That's a very big difference. This area is much more mild, less dramatic, while Wichita, Kansas is very dramatic. Those are complete opposites. So this is an important concept to understand. If there is ever an area that is near a large body of water, they will have mild temperatures. That does not mean, and hear me on this, that does not mean that they are going to be colder. It simply means that they are more mild. There's not going to be a huge range in temperatures. Remember, if you're finding the range of a set of numbers in math class, you're subtracting the highest number and the lowest number. That's what you're doing here. You have the highest temperature versus the lowest temperature. In a place that's by the water, it's going to be very similar. So it's going to be milder is simply meaning more consistent, okay? It's more average. While here is going to be more extreme. That does not mean it's extremely hot, because you can't say 20 degrees is hot, okay? 20 degrees Fahrenheit, that's very cold. but they just have big differences. So over here by water is going to be more constant, and over here is going to be big differences. That's what we're looking at. So because the water heats up slowly and because it cools down slowly, the wind that's going to blow on this area is going to cause the land to also heat and cool more slowly, or the temperatures to feel that way. Because this has no water to help moderate out its temperatures, the land will heat up really, really quickly, and it will cause the temperatures to heat up quickly. And then that land will cool off very quickly, causing the temperatures to cool off quickly. This is a big concept to understand, and it is important to understand. So if you have any questions about this, then I would make sure that you do either send me an email or ask somebody within the class who does understand it. But if you aren't getting this, then don't just sit there and be confused. Make sure you reach out to someone to find out more. So let's look at our last question. Using the information you learned, predict how this could affect wind direction in coastal areas. So here you have a picture of a beach, you have the shoreline, and you have the water. So thinking back on everything you've learned about this lab and the stuff from heat transfer, I want you to discuss within your groups how this would affect wind direction. So go ahead and pause the video while you discuss that. Okay, so looking at this picture, we know that the land is going to get warm fast. So during the day, this land is going to be hot, or it's going to be very warm. This water is going to be very cold. And we know that because we know the difference in how land and water heats. Well, going back to what you learned in heat transfer, what do you know happens to warm air? Well, warm air rises. And why does it rise? Because it's less dense. If you remember, those warm air molecules spread out. Because remember, if you're hot, you don't want to be all up on people. You want your space. The warm air does the same thing. And because it spreads out, it's less dense and it rises. This cold air is going to be more dense, and so it sinks. Now, as this hot air rose, can we have an area of nothing down there at the bottom? No. So what's going to happen is this cold, dense air from the ocean is going to sweep in to take its place. This horizontal movement of air is what we feel as wind. So the way that the information you learned in the lab and the information you learned from heat transfer affects wind in coastal areas is it changes the direction that the wind is blowing. It's either going to blow towards the land or away from the land, depending on how warm or how cold one of those is. And that's what leads in directly to our next set of notes. So we will continue on. You don't need to write this down, but if you think about it, there's temperatures vary all over the world or even within a single state. And the reason why is because land, which we just looked at, land and water, the difference in how they heat. We've talked about altitude. The higher up you go, the cooler it gets. Geographic position, we've already talked about that. If you're closer to the equator, you're warmer because you have more direct light. If you're closer to the poles, you're colder because you have indirect light. We've talked about cloud cover because of albedo effect. Remember, it's going to be cooler in the day and warmer at night. And then we will talk about ocean currents. That's the only one we haven't gotten to yet. But all of those things make temperatures vary. So what heats faster? Land. Okay, what cools faster? Land. AKA land changes temperature quickly. And this is where you need to write that down. So land heats and cools more rapidly than water. For some reason, people get the fact that it heats faster, but they always start to lose the fact that it cools faster. So land heats and cools more rapidly than water, aka it changes temperatures fast. Okay, changes temps fast. Water heats up longer, or instead of longer, it may make more sense to write slower. It heats up slower, and it will keep the heat longer, aka meaning it cools slower. I don't know, my handwriting looks awful. but it cools slower. So it heats slower and it cools slower. So it changes temperatures slowly is another way that you could write that. Now the reason land heats very quickly and cools quickly and water heats slower and takes longer to cool all has to do with something called specific heat, and that is something that you will learn more about when you get into chemistry. But that's the reason behind it. So because of land-specific heat, it doesn't take as much energy for it to change temperatures, and so therefore it can change quickly. Water takes more energy to change it by a degree, therefore it's going to change temperatures very slowly. So hopefully you're about done writing this down. If not, pick it up because I'm about to change the slides. But this is a very, very important concept to understand, so make sure that you do know that. Okay, moving on. So as air heats up, what happens to its density? We've already talked about this, but I'm going to review it again because it's important. So as air heats up, it spreads out. We don't like to be close to people when we're hot. We spread out when we're hot. Air does that too. Because it's spread out, it has less stuff in the area of space. Remember, the formula for density is mass divided by volume. So there's less stuff, which is mass, in a particular area of space, which is volume. So it spreads out. Therefore, it's less dense, so that air rises. Your cold air, though, when you're cold, you want to cuddle. So your cold air comes all close together, and because it's more stuff in the area of space, it condenses. Therefore, it is more dense and it sinks. And if you remember, this is what we talked about when we did heat transfer, and you watched the different videos, and you saw the cans crush. So the air warmed up, and then when you rapidly cooled it, it went close together, and that crushed the can. So this concept is going to carry on with us throughout all of our meteorology units. So I wanted to make sure we remember that. So how would this affect wind? That's literally what we just looked at. We are going to create something called a land breeze and a sea breeze. So it affects wind because you have the warm air rising and the cool air moving in to take its place, and then that changes at nighttime. So that's what we're going to look at now. This is a sea breeze. Okay, it is during the day. I want everybody to draw this in their notes. As I'm explaining this, everyone should be drawing this, okay? Everyone needs to draw this. What you don't need to draw the low pressure and high pressure and specific heat. Just pay attention to what I'm talking about as you draw. So this is daytime. So you need to make sure you have your little sunshine drawn. Okay, daytime is very important. Okay, so during the day, the land heats up very quickly. And because this land heats up very quickly, that warm air rises up. So the land heats quickly, causing the warm air to rise up. Now, during the daytime, is the water going to be warm or cold? Well, according to this picture, as you see, that water is going to be very cold because water takes a long time to heat up. So this is going to have cool, dense air that is sinking down. That cold, dense air is then going to move in and take the place of all that rising air over the land. So really all you need to draw is the island, and then you need to draw the arrows like I am doing. So you have the daytime, the land, you have warm air rising, cold air moving in to take its place. Now, this is what we call a sea breeze, and make sure that you do write that down, a sea breeze. Why is it called a sea breeze? Well, this air, this wind is going from the sea to the land, therefore it is a sea breeze. So because it goes from the sea to the land, we call it a sea breeze. Now, you need to understand this. You need to be able to draw this. You need to be able to answer questions about this. You need to know everything about it. Okay, if I gave you a drawing, you would need to explain why it is the wind is going in this direction. And you would know that because land heats quickly, so during the day the land is hot, so the air rises. Water heats slowly, so that during the day the water is cold, so the air moves in to take its place. Because it's going from the sea to the land, it is a sea breeze. Okay. I am just about to clear this screen and to switch slides. So if you do need to finish up drawing it, now's a good time to pause the video. If not, I'm going to clear the screen in just a second. Okay, so that's what happens in the daytime. Let's see what happens at the nighttime. Nighttime is opposite. So again, what is it that you need to draw? Well, first you need to signify that it's nighttime. If you want to write nighttime, that's fine. Or you could draw a moon, and I'll just highlight the moon. So you draw your little island, and you draw your water, and then you have a moon. Now, because this is nighttime, what's going to be warmer? Well, the water has heated up all day, and the water is going to take all night before it's finally cold again. So right now, the water is warmer. So that's where I have rising air. So because the water is warm, my air is going to rise over it, and so I'll draw my arrow going up. So this air is rising up because the warm water is going to make the air above it warm, and warm air is less dense, and therefore it rises. Now, remember, your land changes temperatures very quickly. So as soon as that sun went down, this sand got very, very cold. And so that cold air is going to move in, and it's going to take the place of that warm air that has moved up. Now, some people ask me, they're like, isn't this just a convection current? Why, yes, it is. Okay, if you wanted to add that in, you could. I'll just draw in green to kind of show you. Once this warm air rose up, because it's increasing in altitude, it would eventually cool, and it would move back down to take the place of that cold air that's moving in. So sometimes you'll see this drawn as a giant convection current. Sometimes you just see it as two airs, one going up, one moving over. Either way, it's the same thing. You have that air circulating because it is heat transfer that is occurring within a fluid because air is fluid. So again, if you had to explain a diagram like this, you would know, well, because it's nighttime, because that nighttime is important to signify, that's supposed to be a star. Because it's nighttime, the water is warm because it takes a long time to heat up and a long time to cool off. So because that water has heated up the entire day, it stays warm almost the all night. It's going to take the entire night for it to cool off again. So that warm air over the water rises. You can't have an area of nothing. So the cold air from the land moves in to take its place. Because that wind is going from the land to the sea, we call it a land breeze. When it goes from the sea to the land, we call it a sea breeze. But this is going from the land to the sea, therefore it is a land breeze. So again, I'm about to clear the slide and move on. So if you do need to finish drawing this, then now is a good time to pause the video. Okay, hopefully this is all good. Remember, if you do not understand something, if something is confusing you, you have to reach out. Talk to me, talk to a classmate. Make sure you are understanding this. Look up more videos on YouTube. But not understanding it is not an excuse to not do well on the test, because you have the ability to figure it out, but you have to reach out. So if you're confused, speak up. Okay, if you're confused, ask another classmate who understands it to explain it to you. Otherwise, send me an email so that I can contact you and make sure that you understand it